Great, thank you for the introduction. Good evening, hello. My name is Ondřej, and I'm sorry. I have to apologize because I will have to leave pretty early today. That means that I will be leaving right after the talk. There will be a short time for questions when the talk ends, but I will be staying later. I have to go home to solve some family health-related business. So in order to compensate the lack of proper time, I created a small demonstration. So most of my talk will be explaining the demonstration website that I created. How does it work, and what interesting pieces of implementations are available. That means that my talk will be divided into 4 parts. The first one will be the demonstration, the Deno demo. Yeah, thank you. And then I will talk in more detail about the 3 components which are used in the demonstration and the Deno itself, the global infrastructure called Deno Deploy, and the product which is called simply KV, which is probably one of the worst names in IT ever, because what can you tell about a product whose name is KV? What does it even mean, right? So let's start with the demonstration. The demonstration is actually available for you to interact with as well. So if I could ask you to open the website, which is either available using the URL here or using the QR code. Hopefully the QR code will take you to the very same address. And this is what you should see on your device. That's if you look from a distance, that's a city made of emojis. My son made that for you. And the point of this demonstration is that you can interact with individual cells and change their emojis. So you can rebuild the city into emojis are available. And as you do that, the experience is automatically synchronized across all the users. So I'm not really interacting with it myself, just trying to see what are you going to do. We have, yeah, obviously, smileys, robots, yeah, and so on. So I'm quite happy that it's actually working, and I'm quite we'll be studying the source code, which is powered. I will probably reset the city once the talk is over, so your artistic creations will be lost in few minutes. Great. So let's get started with the Deno itself, with the tech which is powering this demonstration. Basically, Deno is something like Node.js. It's very similar, and it's supposed to be better in all aspects. And so we as developers are supposed to look at Node.js and evaluate individual issues and deficiencies with Node.js and see whether Deno provides better developer experience, better tooling, better interfaces, and better infrastructure overall. The main motto of Deno is Node.js done right, which is somewhat offensive because it basically says that Node.js was not done right. But we can live with that because Deno was created by the very same person who created Node.js. So I think it's acceptable for him to review the product in this way. So what do we do to make Node.js or to recreate Node.js again in a better way? So first of all, there's no PragueJS. Ryan Dahl, the author of Node.js and Deno, came to a conclusion that the introduction of this concept of this configuration file with dependencies and other metadata is not really useful for the development. So there is no PragueJSON file. Then we have the use of client-side web APIs where applicable. So instead of introducing modules on we are using those APIs which we know from the browser were possible, such as URL alert and so on. And also the Deno itself is being run in a security similar to what browser does. So your JavaScript, which is interpreted in a browser, is limited severely. Cannot do arbitrary stuff with files. Cannot do stuff online. A list of HTTP requests is being automatically blocked if they don't pass the origin check, and so on and so on. And the Deno itself introduces a similar sandbox, so that if we run a foreign code, some source code which we do not trust, we limit what the source code does, whether it can access file system, whether it can access network, and so on. The Deno itself is distributed in one file, so when you install Deno, you just download that one by Unix operating system, you then Deno ecosystem and infrastructure available. And this one binary, that it can compile your code, it can bundle your code into a binary executable, it can lint, it can run tests, it can run benchmarks, it can summon ghosts, no, not really, but a lot of other stuff. And the Deno leverages TypeScript as the first class language. So you can either feed it JavaScript or TypeScript or their X extensions, JSX or TSX, and it transparently transpiles TypeScript down to JavaScript. So this is the short overview, and we have a list of similarities because all these, both these runtimes have the same goal, the same ambition. So which are the similar aspects? We have them available as server-side runtimes built over the V8 JavaScript implementation, the very one that powers Google Chrome browser. And they both have a standard rich library. So you don't have, you not only have the binary executable, you also get access to the rich standard library that you can import and use. The JavaScript asynchronicity is also present, so all operations which use the I/O, such as file system access or network access, are completely async. And there is a strong focus on writing HTTP servers, on writing WebSocket servers, TCP servers, and so on. So those are the prime use cases for both Node.js and Deno. But we have a Node.js was written or is written in C++, while Deno is implemented in Rust. The dependency management is completely different because, as I already said, there is no PragueJS, so instead of that, you specify your dependencies using ES6 module import and export expressions. We will have a look at the source code in a moment. Leveraging web APIs were applicable. So there is a list of web APIs which are freely available out of the box without using polyfills, without using modules. These are completely built into Deno. So if you work with these APIs normally using client-side JavaScript, you can already use them in Deno and they will work as well. And but the big difference is that you can write your TypeScript without transpiling it manually down to JavaScript. So you only run Deno, Deno space run space source code.ts, and that's it. So those are the differences. Now let me focus a bit on the security aspect. The point is that you often you often run code which you need to trust somewhat because you download the code from the internet. And that's hard. You're normally told not to really download binary files and execute them because you don't know whether they will harm you or not. And it goes because basically there is no difference. You can inspect them, but you typically do not do that. You're often told to install this tool, just copy-paste this shell script one-liner into your don't do any harm. Trust me. And there is a certain level of risk. So in Deno, when you run a file, by default it's a complete sandbox, cannot environment variables where secrets are stored, cannot access your file system, and so on and so on. And in order to allow your script to do so, you have to individually enable all these access flags manually. you can do that. You can do that globally, or you can do that individually per permission when you run the file. People often ask about Deno maturity. How old is the product? Is it used by someone? So is it stable? I think that, yeah, the Deno is mature enough. It's 5 years old now. It's using strict semantic versioning. So if you depend on a particular version of a library, you are guaranteed to remain backwards compatible. Deno is rather stable. I personally run Deno for several web services, such as the Emoji City, which you might have experienced already, and some more serious server applications, and they are all stable, no crashes so far. There is a large amount of documentation in Deno. We will have a look at that when you use a standard library function or a class. It will be always properly documented online. And yeah, we can also host our own modules on a public place on the internet. Think npm.js.com or something like that. For Deno, that would be deno.land/x. That is a place where everyone can host their modules. So we now have to look at the source code of the demonstration page that I provided. We'll have a look at the modularization aspect. We will have a look at how HTTP is handled, and we will see that the source code is completely written in TypeScript. So the problem here is that the resolution is kind of crappy, so you cannot really see the whole source code at once, but I will try to somewhat fix that by scrolling and explaining. So this is the whole application with the Emoji City. It has 75 lines of code. That's not that much. That's the server part of the application. There's also a very small HTML, CSS, client-side JavaScript component, which you are loading into your device. But, well, who's writing client-side JavaScript these days? Haha. So we're focusing mostly on the server here. So let's start with the modularization aspect. We have these ES6 import statements, and we're doing that to include stuff from the standard library. So the specifier links to an HTTP URL hosted at deno.land/std. That's the standard library. And these lines are rather long, but we can visit these. We can open them. We can see the implementation of the standard library. It's written in TypeScript, not really surprising. And we can even probably copy that, go here, and paste that URL, and we can check out the module online, and we will not be visiting the source code itself, but the auto-generated documentation file or page, which is handy, because that's what we often want to see, the docs, not really the source code. So yeah, that's for the standard library. These are traditional imports compatible with other JavaScript things. HTTP part. So we were importing the function called serve. That's the HTTP server component. And the serve function is an async function that needs a handler, something that will transform incoming requests into responses. So where do we have the implementation of such handler? Here we go. It's an asynchronous function that takes a request, and the request is being typed as request. And this is the very same request that you already use if you use client-side fetch. So if you ever use the fetch function, you probably know that this API comes with a set of interfaces. The request class, the response class, streams, bodies, enums, headers, and so on and so on. And we have these existing web APIs, fetch, and so on, here in Deno. So this is your traditional fetch request, and the fetch request has a list of headers, and for most of the time we will be processing either WebSocket connections or static file requests, so that's why we have this if-else branching. So the static component is pretty easy. We check the URL, and we resolve that using the function serve file, which is a built-in static file server. So if you need to quickly pass through a static file from a file system out as HTTP response, we can leverage that. The serve file function is being imported as well. And if you on the page itself, the HTML page, the client-side JavaScript will try to communicate with the backend using a WebSocket connection, because we often want to only. So WebSocket is idle for that. This is kind of special because standardized API. This API was created by Deno creators because there's no client-side equivalent for that. The server connection in client-side JavaScript. All these APIs functions are included in the Deno namespace. So all the standard libraries to work in a traditional fashion, and things which are highly specific to Deno. And we accept the socket. We add that to the list of our clients, and we add these listeners. And if you ever worked with client-side WebSockets, you see that this is the very same API that we use. So these sockets, this one, that is a WebSocket class, the very same that you use in client-side JavaScript. So we'll be communicating in the same fashion that we communicate when doing client-side stuff. So we have these callbacks on client message, on client open. Let's check them out. On client open, yeah, here we have the event handler. It's doing something, not really relevant right now. And on client message, when the browser sends us something to do. That would be the examining part. We go on to other stuff. So we now switch to the part of the talk and the code which is called Deno Deploy, and that's how we run the code, because typically you can run the server yourself, but that will be on your local machine. And I need a server-side environment publicly available with a public IP address and public DNS name where my Deno can be run. So we will be using Deploy for that. Deploy is a service, a hosting service, where you upload your TypeScript Deno-based HTTP servers, and they run that for you. That is a certain amount of luxury in that, because it's for free. And if your Deno scripts are too large and they take too much of CPU time, you will get billed for that. And I'm not sure about the price, because my scripts are small. And the deploy is being run in individual data centers across the world. They have 34, I think, localities. So basically, when you type the URL into a browser, such as PragueJS.deno.dev, then we are hitting the Deno Deploy service. In particular, we are hitting the closest data center that is located closest to us. And you can deploy stuff either by pushing to GitHub repository, that's what I'm doing, or using the CLI. There is a subcommand for Deno called deploy-ctl that will allow us to push stuff to Deno Deploy, and also using an interactive playground online, so you can prototype your code fast in the browser, and the code will get deployed to a public address to experiment with. So that's pretty strong. Here is a small drawing that I stole from the internet to show you how the Deno Deploy infrastructure works. And when talking about Deno Deploy, we need to focus on the middle part, this called edge nodes. So the idea is that these are your devices eager to view the emoji city. And they use HTTP to communicate with these individual edge nodes, those servers where Deno is being run. And now, we are only so far focusing on this part because we are all located in the same geographic region. So we all are hitting the same edge node. And that's cool because it allows my edge node using the broadcast channel API already without Deno, because it's a standard MDN documented web client-side API. Anyone? Broadcast channel? 2 of you. Wow, I wasn't really expecting that because, in my opinion, there basically is no real reason to use that, and I might be surprised by your particular use cases. This is a rather obscure API which allows you to synchronize stuff across multiple browser pages running the same application of yours. So you open 3 tabs, do stuff in one tab, and you want other tabs to be synchronized, notified about that. And the broadcast channel is what we use when doing client-side JavaScript. And the Deno team is using the same API to sync stuff across multiple data centers. In the future, this API will be also used as an inter-process communication primitive. So you'll be able to run multiple Deno processes on one machine and have them communicate together using this broadcast channel. So let's have a look. Let's have a look at the implementation. What are we doing with the broadcast channel? So we're having an instance of a broadcast channel here. It's called BC because, naming things is hard. The new broadcast channel needs a textual label, and I decided to provide an empty string for that. And we're using that broadcast channel in 2 parts of the code. So first of all, when we receive a message from the WebSocket from one of our clients, say that you want to change one of those emojis to unicorn, we need to distribute that information to all other sockets. And as a bonus, we also distribute that information to the broadcast channel. So we're treating the broadcast channel as a communication API, as a communication link to all other data centers across the world. And obviously, in a symmetric manner, we are listening, we're having a listener, a message listener, on the broadcast channel. So we process the data that comes from other data centers, and we're treating it pretty similarly to events that are coming from clients, just that there is no need to this data to the broadcast channel back, because that would be useless. That would create endless loops and so on. So that's the broadcast channel, pretty interesting and important thing for us. Fine, let's move on to the last part of the talk. I think I'm somewhat running out of the time. And that is the famously named Deno KV. The KV is really modern. It's really beta right now. It's really unstable. If you want to run that, you have to pass a special flag to the Deno binary called unstable so that we can use that. So it's pretty raw, and I think the API might be changing a bit in the future, but the concept here will remain. And the KV is a central point of your application. It's a database which is shared across all these edge nodes. So when we switch here, we can and should have a central point which was conveniently labeled cloud, but this is cloud as well, right? So this would be the Deno KV, a database, and we have some expectations about the database. We want that to be resilient, and we also want some consistency guarantees. So let's have a look. What do we have using the KV? The KV name means key value. I guess you figured that already. And so we store pairs of keys and values in the database. And now when you're using the Deno Deploy infrastructure, the database is backed by the Foundation DB. That's some Apple open source stuff. And if you run Deno locally, then all your data stored into Deno KV will be stored in a SQLite database file, so you can comfortably inspect that yourself. And we're able to store values which are JavaScript values, and we can use complex data types. Anything that can be passed around using the structured clone algorithm can be stored in Deno KV. So we're not really limited to primitive data types. If you are used to local storage or session storage, then you know that only primitive data types or strings can be stored, and we're able to store complex data in Deno KV. And we have both consistency modes. We have eventual consistency, where we get our data fast, but not necessarily correct. And we have strong consistency mode, strong reads, when we are guaranteed to get the latest copy of the data. And there is a support for transactions, so we can do multiple reads and writes in one transaction that will automatically get rolled back if one of those fails. And the data is version stamped, so anything that's inserted automatically gets a counter, and we can use these counters to compare versions to see if the data has been overwritten by any other edge node that was trying to write into KV. I will show you the API, not really by studying my code, but by having a small example. We will be opening the database in an async manner using await open KV. Again, this is Deno-specific functionality, so it's available in the Deno namespace. And we will be setting stuff, we'll be pushing data into the database. And the signature for set means a key and a value. The key is an array, actually. It's a list, and we will see why it is a list in a moment. And we're setting the value 42. We will get back, well, after a promise fulfills, an object with the version stamp that has been given to our data. So we can try reading the value back with the same key, an array or a list with one string test, and we get the value which we stored. And we can then use a transaction. So the transaction is a complex beast. We started by calling atomic. That will create the transaction object. And the first one will using the method called check. So we will be checking whether the transaction can be processed, putting a value, a particular value, this one, and testing whether the value is still there. So if someone executes a different write here somewhere between lines 5 and 6, the transaction will fail because the version stamp of the data stored under the key test will be changed. So this basically means continue with the transaction only if the data has not been modified. And that's pretty much necessary if you wish to handle parallelism. And we'll be setting a new value called test with the value 43 and committing the transaction. And we have the guarantee that it will either fail or increase for 43. And that's it. The actions work in KV. Now, those KV keys are arrays. And those are arrays. So you have to think a bit differently about structuring your data. Are used to storing database or storing data in tables using relational approach, tables, columns, and rows, and so on. And we are using a different approach. We're using keys, which are sequences of primitive values. So I have a set of examples of keys that might be useful. For instance, the key of users, 42, and profile. That might be a way to store information about a particular user, 42 being the user identifier. And this looks like a name of a table. You might be using a database table called users, and then you will have a row with ID 42 and then field called profile and so on. And instead of that, we have this path, looks like a path, right, to the data. And the data can be looked up, back, only using keys. So we need to be careful that is necessary for retrieval in the keys. We cannot really which are stored in the database, all the individual cells of the city. We are using, the database is open, yeah, Deno open KV, and we're listing all data, and we're listing using a prefix listing, so I'm interested in all keys and all their values. That's basically the dump of the whole database, because I want to read all the contents, all the emojis in my memory, so I can then pass them to clients. And I read them using an for await loop and store them locally in my memory. That would be the data variable. Yep, that is a map from the set of coordinates to the emoji. When a message arrives from the WebSocket, that's our listener, we already saw this code, we need to write that to the KV. And that's all. There's no need to wait for the database to process that write, because we are also storing the data locally, and we're also notifying other edge nodes, probably, not sure if there are any, but there could be, about the change. So the KV store is there only as a fallback, because our edge node might get terminated when there are no users. All the memory will be freed, all of this script will get terminated when we all close the page, and we need to store the data, and the KV will be the storage. So when you PragueJS Deno Deploy, and the node will initialize itself by reading the state from the KV. So that's the only way I'm interacting with Deno KV in this example. I have a list of links for you. The slide deck of mine is available publicly on some URL. I might tweet about that after we end. So you can review the talk itself, review the emoji town yourself. What are these links about? The first is pretty impressive talk by Ryan Dahl in 2018, where he introduced Deno itself on a conference about Node.js. That was pretty adventurous of him. We have a link to the official Deno manual, documentation for the deploy, a talk about internal architecture if you are into Rust. And this one is my own talk 2 months ago at Web Expo, where I was giving a similar talk about Deno, but the talk was structured differently. There was no demonstration. I created the demonstration during the talk, and well, yeah, you can have a look if you want, if you're interested in Deno. So thank you, and I think that now is the time for questions if you have any.